dealers just like you around the country. And now we're really stepping up. So one of the cool things, Mighty Bite, how many of you guys know who Mighty Bite is? So fixturing, they saw these, they got jealous. So they actually did the same thing and actually made a kit with everything that you need for what we call the art of fixturing. So I'm like, that's my whole philosophy here. It's like, this is really not that complicated. So let's actually just walk you through everything and teach you how to CNC machine, teach you how to make lathe parts, and actually get you through this quickly instead of spending so much years and having this the only thing that you learn. So we can actually get you to a place where we can actually teach you how to compete and be a pillar in a shop so you can actually make good money. And that's why our next series is the art of fixturing, which just came out and a lot of people are making it. And what it is basically you make this base plate down on the bottom, and then the smaller plates, each one has a different system of holding a part from raw material to a finished part. And each one has a different type of clamping that teaches you how to hold hard to hold parts without having a vise. So if you're looking at the red part up there, you could actually just keep making those same fixtures all the way down, and depending how big your machine was or your tombstone was, you could just fill it completely up. And then while the machine's running, you could load raw stock into a base plate or a subplate and actually pop it on there, boom, and then just run so that the machine's running 100% of the time and you're loading and unloading while the machine's running. And that's what we do with pallet systems. And if somebody had like a bunch of, say you had these 4 different parts, you could actually have that base plate in, you could take the top plates, you basically lock them in, just go to the program, run it, take that job out, put the other one in, instantly go to that part number, run it, and you can change, basically turning on a dime that quickly. And that is elite fixturing. And we make it simple. And guys who literally, we have a guy, Corey. I just hooked him up. He is online. His dad owns a machine shop. He didn't want to follow in his dad's footsteps and didn't want to be an operator. And then last summer, he ran across the academy. He taught himself how to program. He did all the parts, and then now he's doing these parts. And I was so impressed with the parts that he was putting out, just having learned how to do it on his own, just working on a machine in his dad's shop, that I basically contacted Mighty Bite on there, tagged them, and said, you guys should actually put these fixtures in your IMTS booth and actually give him like some free hotel rooms and hook him up. And so now Corey gets to go to IMTS Chicago on Mighty Bite's dime, and it's a good thing. But you know, the whole point is like, here's a kid that didn't want anything to do with it, and then all of a sudden he learns how to program. Now he's passionate, now he's making all the parts, and his dad owes me like dinner or something. But yeah, elite fixturing. This is live tooling, so we have lathes now that have mill spindles in the turret that actually can do lathe turning and mill at the same time. It's just kind of an ordinary thing that happens in any top shop. And so this is a series where kids and students and machinists can actually create their own chess pieces. And we're actually making the pieces out of 360 brass and titanium. And you basically make all the parts, and then you learn how to use this machine. And once you go through everything, you can pretty much make anything. So just another cool project. And what's cool is when you actually look at these, these are actually solid models, but basically Billy just put it into an environment and took a picture of it at an angle, and that's what you're seeing. And then 5 axis. So These are, so we got from super simple parts going all the way up, and these are some of the more complicated parts. And basically, we're just going to teach you how to, with tutorials, teach you how to do real 5-axis parts. Like, let's not like just do little squares and holes and stuff, but let's actually get kind of complicated and show you how to do parts that matter, that it's going to get you a good paying job. And so one of our big things is just the sheer amount of projects that we're coming out with. This is not even close to how many we're going to have, and that is so you can go from part to part to part to part to part and actually just make it happen. So 5-axis, again, greatest country in the world, and there is no 5-axis curriculum in existence unless you make your own. And then this is another step up. So you look at Parker fittings, and you look at aerospace fittings, and all the top aerospace companies, even subsea companies, they all have different fittings and stuff. And what they do is, instead of actually having a print that has every single dimension on it, a lot of the top shops now are actually calling out a specification for a specific port or a thread, where it actually, you have to go look into that actually specification, and it's going to give you all the dimensions for that particular style that they called out. So they don't have to spend all the time to make this very complex. They can just make one part, have a whole bunch of line items, and then it changes based on the aerospace spec. And so that's how these prints are. You actually get the spec, and then you have to go in, do the research, and then actually create the parts. And that leads us to our community. So one of the cool things is, like, we're talking about educating our kids. We're talking about getting them excited, right? So one of the cool things about what we do, about having the only TV show on American manufacturing, about having just hundreds and hundreds of thousands of people that follow us, is that the kids follow us, they get excited, and the whole thing just keeps getting bigger and bigger and bigger, and now they're all communicating around the world with each other, and it's awesome. And I'm asking Matt to actually step up, and he's going to talk a little bit about our community. Thank you, Matt.
How are we doing?
Good.
Boom!
Boom! My name is Matt Schilling. I'm the Vice President of Titan CNC. So thank you very much for having us today. We're really excited to deliver this content to you. And we're excited more than that to see these parts in action, see these kids making parts, learning a skill. So this isn't a theoretical curriculum. This is not a theoretical idea. This is something that is happening all around the country and all around the world. So we want to be able to illustrate that just a little bit for you today. Titan's mentioned it a couple times. We have 35,000 Academy members, and this is within our first year of launching our curriculum. So about a year ago is when we started actually building out the curriculum, coming up with the ideas, coming up with the parts, and it's caught on like wildfire. And that's an effort that we've done basically part-time. Titan's, as he's mentioned, is building aerospace parts. That takes a lot of devotion, takes a lot of time. So now that we're going into a full-time development for a curriculum, it's going to continue to expand forward, and we're expecting great and tremendous growth. Just some of the demographics here. You can see what's our major demographic there? Machinist. And when we look at it, it's like, oh, that's interesting. But what we find is that machinists are the ones that really want to dig deeper. They want to learn and understand programming. And so I think from your guys' perspective, what you should look at is this is the industry speaking. They look at our curriculum, they see value. They see something that they can learn, and they can contribute to their own business or their own employer. So it's something that's practical, that they're able to learn and grow by utilizing our curriculum. Students, obviously, something that continues to grow. Teachers, 1,600, hobbyists, 5,500, and other there. But other thing I'll point out is our teachers, oftentimes they're utilizing our curriculum, but they don't actually have their students sign up. So I think it's really important. We want to make sure that each student has an opportunity to create an account, which is free. So if your students aren't doing that, please have them do that so that at home they can actually see this curriculum, watch the videos, download all the content that they would need, including prints, including models. It's all available for free. And I think this is what will tie things together. Kids are so comfortable with technology. They utilize their phones every single day. They're on their computer every single day. So by giving them the resources they need, they can take the things that they're learning in the classroom and apply it to their home life as well. So currently in our demographics, we have about 1,500 machine shops with 50 plus employees. So the influence is heavy there, and we often see this is where it starts. You start the little integration of some of these skills that they're learning, and that helps the business grow, that helps the skill set grow, and they're able to expand and go beyond what maybe they thought was possible. 4,500 machine shops, 2,000 educational institutions, includes colleges, includes high schools, charter schools. And so when you look at these statistics, go back here. We wanted a way to bring it in all practical. And so, as I mentioned, everyone's comfortable with using their computer, using their phone to utilize this content to understand how to build a part, how to design a part. But we wanted a way to actually bring it home for them. And maybe all students don't have access to a CNC machine. So Titan and the team, we came up with an idea for small groups. And small groups are located all across the world. This is an actual map you can see on our website at academy.titanscnc.com. And you can actually locate shops all around the world that have opened up their doors to outside individuals, non-employees, that can come in on a Saturday or a Sunday and actually learn through our curriculum at these shops. So if they don't own a CNC, which is at a crazy expense, they can still learn in a very practical sense how to machine these parts, which gives them a future skill that they can apply to their employment. And Jacob here actually leads a small group at his old high school, right? At Rockland High School. So he's taken what he's learned through the curriculum and applying it as a teacher. And so giving them empowerment, giving them the opportunity to expand their influence is something that's really, really profound.
And I see that parents are showing up also. And they're like, my son, my daughter is like learning this. I want to learn it. So pretty awesome.
It's awesome. And I think it's important, as I mentioned, to understand what we're working with here. Kids, young individuals, there's a tremendous influence from social media. And we want to be able to illustrate the fact that in our environment, we're really focused on that online mentality, being able to give content to everyone, everywhere, because these are the types of statistics that we're looking at. On YouTube, there's 1 billion hours of content consumed every day. Isn't that insane? It's pretty crazy, right? And so we understand that, and we want to be able to contribute to that and meet kids where they're at. For Facebook, 1.94 billion monthly active users. Instagram, 800 million monthly active users. And Titan mentioned the statistic pretty quickly earlier, but adults are spending about 2 hours on social media every single day. For kids, it's up to 9 hours. Isn't that crazy? So statistically speaking, some of you have probably checked your Instagram while I'm talking, so I'm watching you, so keep going. So we need to meet kids where they're at and understand that our influence can extend beyond the classroom. And so utilizing our curriculum and coming up with content that's going to excite them and give them some inspiration for what they can do in the trade is something that's very powerful. Just looking at some of our statistics here, we have tens of millions of views across all of our social platforms. 100,000 visits to the Academy each month. Those are active users that are coming back for content. They're looking at the videos, they're downloading models, they're downloading prints. So they're actively using it and learning from the curriculum. We have users in 170 different countries. I told that to somebody the other day, like, are there 170 countries? Actually, yeah, there's a lot more than that. But it's crazy to think that all areas of the world, places we've never visited ourselves and stepped in physically, are utilizing the curriculum to learn. So this is something that's tangible, and the industry sees it and sees value in it. And that's it. So just kind of wrap it all up. we love and eat, sleep, and breathe manufacturing. We love CNC machining, and so we want your kids, we want your students to love it too. And we want to be able to show that it's cool, that it's relevant, that it has a future. The future is bright. And if we can apply the techniques, the project-based learning that we're focused on here in the Titan CNC Academy, we believe that this growth is going to be even bigger. So, thank you. So I'm going to hand it over back to Titan and Billy. And I'll introduce Billy. Billy is our lead engineer at Titan CNC, so a lot of the parts that you've seen today, he's actually helped design and come up with in partnership with Titan. So they work very closely together. And we're going to actually see a live demonstration here of what it actually takes to actually model a part. And let's take it from a theoretical idea that we've talked about all day to actually see how it works in practice. So pretty exciting stuff.
You know, one thing I'll say is that I mentioned it earlier, but last Friday I put it up and I just said, hey, if you are a company and you believe in what we're doing and you will hire students, will you actually fill out this form? And we had 680. So think about it, just in 1 week, and every day it's compiling. So what we're doing is we're showing the amount of companies, we're showing in just a year's time, we're showing the amount of machinists, we're showing how all these major companies, even big aerospace companies, are actually saying, we see value in the academy. We want to hire people who are doing this. This is what needs to happen in our industry. I think you should take note, because what we're actually doing is we're actually becoming the industry standard, period. And there's nobody even close. There's nobody even close. If there was, I'd be doing something different. So we're just take a couple seconds.
I have a question while you're...
Yes.
You stated that there was going to be, did I hear you right, 1 million jobs? What did I hear you say?
So there's, and within the next 10 years, there's 3.4 million jobs that are going to become available because a huge percentage of our workforce is retiring and they're over the age of 50 years old, right? 2 million of those jobs will go unfilled because there's nobody to fill them. So as the masses who were busy in the 60s, 70s, and 80s are retiring, there's no kids coming into the system. There's not enough of them to actually keep the whole thing moving. So as manufacturing is coming back, we just don't have enough people getting excited, and that doesn't include all the high tech. When you start looking at hyperloops and you start looking at the rocket companies and the medical, and you start looking at all these things, nobody's even talking about that. And all those actually take complicated machine parts and stuff. And everybody talks about 3D printing, but 3D printing is still a specialty, and you know, it got real popular and stuff, but it's not going to take the place of this. It allows you to make additional awesome parts that we couldn't make before. You know what I mean? And which is awesome, but it's in addition to. Any other questions? While we have a minute, what's up, bud?
You mentioned the school.
Yes.
Is it open now, and where is it?
So the school we built a school in San Quentin prison as an example. I'm taking my CNC shop and basically turning it into a school. And that we're in the process of doing that, and our first class is actually on the 7th of May, where we have a team of sales men from Kennametal who are actually coming over, and we're going to teach these guys how to actually design parts, machine parts, you know, program parts in a 3-day course where they leave with actual 5-axis part in their hand.
When does that look for teachers?
That we're probably looking at the summer. So right now we have, with teachers and business owners, we have close to about 1,000 on a waiting list. That's how popular it is. So,
Where's that waiting list at?
it's actually, it's up on the academy.titans of CNC. If you go to resources, and then I believe it'll say live workshops. And who knows, you know, we're going to put it, when we put out our first date, then we will look and take people from that list. But I'm sure there'll be some people that can't make it and stuff.
Anything besides just a 3-day workshop, or is that what?
Well, my focus is that I don't want to teach the students, right? I want to teach you to teach the students. And that's where I really see the gap. I see the gap as there's a lot of teachers that want to step up. They just, like, they're not working at SpaceX. They're not working here and there. So let me pick and choose my battles. And I see a real need where people charge these teachers like $3,000, $7,000. It's crazy. And what do they learn? Like nothing, you know? So I'm just like, and then people like pay me to go to speak at these big events. And I'm like, what do you learn? Like, it's cool to talk to everybody and watch PowerPoints, but like, let's buckle down and actually make something that's legit, you know? And that's really the heart of why we're doing it. It's just like, let's make it happen.
It would be great just to get a little bit of info when you offer those trainings and something in more detail down the road.
Yep.
I got Jacob's contact, so should I just?
So, you should be, everybody here should be like, just go up. It's free. We don't share your information, not even with our partners, nobody. But you just put your username and a password, and you join the academy, and then you will get updates when the classes come.
I noticed you have a badging system in your forum, and it says license is completed your advanced user tutorial. Is that just within the forum, or is that going through your program? You have a badging, so as a user goes through your program.
So what does it say?
It says license completed our advanced user tutorial. Now, is that somebody who's gone through level 3, level 4?
Yeah, you know, so what's happening there is you have teachers from around the country that are going on there, and they're speaking to each other.
Okay, so that's just within
And
the
they're,
forum.
yeah, so in the forum, that's a way for you guys to
That's not
speak
monitoring
to.
students who go through your training tutorials.
Yeah,
And
so we're coming out with certifications that teachers will be able to give, right? But that just wasn't my biggest priority. My biggest priority was the content behind it,
We gotta
right?
get that first.
Exactly. So people keep telling me like, sir, and I'm just like, I just been focused and are we good? Cool. I wish there was a way we could put that. You can't split the screen, right? Okay. Okay. So let me explain. So we talked about SolidWorks. SolidWorks is an amazing software. It's been around for a lot of years, and a lot of people are used to it. I get the pros and cons. I hear people all the time, and it's really like Chevy and Ford, right? Some people are just used to it. They've worked on it for a long time. I have SolidWorks at my shop, but there is a migration literally online where people are just coming over to Autodesk. And it's not because, you know, I don't make money saying this, but it's just because one is you can open a machine shop and actually get it for free, and you don't pay any money until you make $100,000. That's pretty awesome, because when I started my shop, I had to go buy SolidWorks and go buy a CAD/CAM system, and it was a lot of money, right? So Autodesk, they're investing in the future by making it affordable. So when I first met Carl Bass, he came and talked to me about Fusion, and he said, Inventor from Autodesk, which competes with SolidWorks, is never going to overtake SolidWorks. Even if it gets better, in people's minds, it will never be better. But we're coming with something new, and we've purchased over 100 different companies, and we're calling it Fusion, and we're taking the best from Inventor, we're taking the best from Delcam, the biggest CAM company in the world out of Europe that they actually purchased, and we're taking waterjet and laser and engineering and shopman, and we're putting it all together in a platform, and then we're going to make it on a cloud, which is cool because the teacher can actually be up in this kind of portal with his students, like in the cloud. Kind of cool, right? But up there and actually check the students' work without them handing in anything or actually sharing files or anything, and it's pretty awesome and stuff. So we teach with Fusion, and one of the cool things is that when a student graduates from school or when he's at home at night, he can actually work on his own designs, his own assemblies, his own everything, and because it's free for all education and hobbyists. So this is Fusion 360. And again, if you use different softwares, one thing I say is like, just like look at the ease, look at everything. So we're just gonna run through the drawing of the Titan 1M. You guys saw the part, it had the inside pocket, and there's 3 prints. So the first one was just a box. I know the part, so I know it was 0.750 by 1.9 by 4 inches. So Billy's just going to go ahead and create a rectangle. He's going to collect his surface. So hold on. So he went up. Actually, can you do that again? Go ahead, now watch. He's just going to say sketch. He's just going to click that surface right there, which puts 0 right up there. He's going to do a rectangle. He's going to click the center. So he and I do it different, but he's better at this stuff. So basically you can see the little tabs come up. So he's going to put 1.9 by 4 inches. See it? So he created a rectangle. Now all he's going to do is he's going to hover over it, and he's going to right click and he's going to hit press pull. And then just instead of putting a dimension, just grab that arrow right there and pull it. He can just, that's how he makes a solid model that quick. So if you put 0.750, so that's the first drawing on the first print, and it's literally, it's just that easy. So
How do you zoom in and zoom out on it?
just scroll in and scroll out.
I gotta.
Oh, you're doing it too?
Regular mount.
Yeah.
So now think about this. You don't have to follow it so much, because all you have to do is go to our academy and click on this one, and there's a video that teaches you exactly how to do it, and you just copy it. That's it. So the next print is going to be the 1032 threads. So he's going to go grab his locations. I can show you so the next print just has the threads on it. And it has locations, so
I'm just going to throw them down. I'm not going to give them any restraints or anything. And now I'll add dimensions. So I kind of have them where I want them.
So you just want to create point,
Point down.
selected a surface, you wanted to put a point. What's up, bud?
In your tutorials, do you discuss the little details? I noticed when he extended his block,
Yeah,
he pulled down
yeah.
as opposed to pulling up.
Yeah.
Can you explain why?
And we explain every single thing. And when I first started doing the CAM, that's the cool thing, because like, I'm not a SolidWorks guy or a Fusion guy, I'm a machinist.
Yeah.
So when I grab his, I reestablish my 0, and I say I'm going upper left. So while I'm doing the tutorial, I'm saying, why am I doing upper left? Because I'm going to have a left-hand stop, and I'm using a single station vise with a hard stop in the back. So I'm establishing my 0 right there. You know what I mean? So as we go through, I'm doing it. There's a lot of guys who are in the 3D world where they're like, oh, you got to put your 0 at the bottom and do this. And I'm like, you know, I'm going to put it at the top on these parts. Maybe different on the 5 axis, but I'm going to do it on the top because I want the guys with the understanding G code so that they can see their negative. Anytime it's a Z negative, they're in danger. Anytime it's a positive, they're in the sky. So I literally am flying around saying like, okay, now bloop, bloop, we're going in the water. You know what I mean? So that people understand it. So as a machinist, I just have fun and I'm just joking around, but I just teach you the trade while I'm teaching you how to like do the tools, you know what I mean?
Yeah, those little details can take a long time to,
Exactly.
a lot of money to figure out
Exactly.
the wrong way.
Exactly. So now Billy's just doing the dimensions. One cool thing when you're on here, you just hit D, and it puts you into this, and you just click the edge, click the dot, pull it, and basically put your dimension. So in the video, you'll see exactly, and even when he comes in, and we have fundamentals also, so you can go into our fundamentals and you can actually, it'll just go through and show you how to use all the different little things and stuff if you just want to go play around. Are all the fundamentals for Fusion up?
Fusion for sorry,
For Fusion, the fundamentals, are they up yet?
Yeah, all the workstations.
Okay.
We're adding more to it, but the
So what he's doing now is instead of dimensioning all of his points, he did just the left side and the center, and then he's going to mirror it over to the right side. So you can see the center line, and then boom. So now it's a 1032 hole. That it's funny, right? Because the drill size on a roll tap is actually 177, but the ID of the thread, because it pulls back, is actually 0.159. So he just selected each one of those and then basically just popped in the diameters for all of them. You can change the angles at the bottom, you can change. Why don't you, since you're doing it, why don't you just talk them through? Now he's gonna take those diameters, and he's gonna create a thread partially the way down. So if, let's say that it's 750, and then the drill hole goes down 600 deep, then he's probably gonna go with the thread down to like, was it 3/8? 3/8, which the tap will have a little bit of a lead, so we want that extra space. So he just changes it to a 1032. You can see it before he even clicks it.
Yeah, the neat thing about Fusion is it'll actually model your thread, so you are able to 3D print it and those threads come out right.
Is there a place to make a counterboard or anything like that?
Excuse me?
On this one, there is a big pocket in the middle.
Yeah. So this is the second print.
Yeah, just finishing that up. Now we're on the third.
So now we're gonna go and do the pockets in the center.
So again, I'm just gonna start a sketch. I'm gonna put the sketch on this top surface here. And it has a 300 thou wall all the way around the pocket. So I'm just gonna do an offset. The whole part. Have mine as a 300. And I see I have a couple skin around these guys here.
So he just did a circle, clicked right in the center, pulled it back. As soon as he stopped, it just said, gave him the dimension, he just filled in the dimension.
There are the
Oh, so you
scope.
can highlight it and then just shift the
Yes,
dimension
you
over.
can steal other dimensions that you've already set. I could also just tell it be equal to another one that has a dimension, and I can change them all at once just by changing one dimension. Lots of different ways to do it. There, I'm just doing a line, creating a tangent link, that you can drag it around. I'm just gonna snap it to this line here, and then I'll add a dimension.
So that's the angle.
Again, I'm gonna create just a little mirror line, so I can mirror stuff.
So now you can see when he actually scrolls over, when his cursor goes over, it actually is already looking for spots that it can extrude.
So you can see like that's an area that's closed off, you're able to extrude it or cut it. Lots of different ways.
This diameter is from here. So we got him on the first part. What happened, and the thing is, I actually did the tutorial for the Titan 1M. He did the second, third, fourth, fifth, sixth. So, this is the first time you've gone with this one before, right? Long time ago.
Yeah.
So all he did was the top diameter, which was 0.625. It was a smaller diameter down here, like half the size, basically, almost half the size. So now he'll put that at the 45, and then run them parallel at 300, and then he'll have it. When are we talking? Question and answers in that thread.
If someone had a little bit of AutoCAD experience,
Yes.
would Fusion be pretty?
Super simple, it'd be super simple, and if you just, doesn't even matter if you have experience, period, if you just watch the video and just copy it, I'm telling you, it is that easy. So, 6-year-old kids, I'm telling you, like, you just gotta, adult, and you know what's, and what he says, adults struggle more, and it's only because they try to go too fast, too quick. You gotta slow down and copy every single thing and take your time. After you do the first one, you'll get it quicker. Yeah, so this software is actually Fusion, so all you have to do is go to my resources page, and it will say download, so you just download it, and just tell them that you're in education or you're a hobbyist. Hobbyist is almost the easier way to get the multi-year, right? Yeah.
Is there a way to know if your 2D sketches are fully constrained on there?
You can tell by the color. The lines will turn fully black when everything's fully constrained.
So, let me just say something, so that answered that question, right? So what Billy's doing right now is that he has a radius in that corner right there, and it's probably like a 187 or 190, right? 195. So all he did was click each corner and then put 195, and then automatically just changed all of them at the same time. So.
And I find most of the time that adding fillets and stuff to sketches can be problematic down the line if you make adjustments or anything. So I choose to do it in the solid environment because they'll adapt easier.
Yeah.
If you highlight the inside and outside radius is the same, should be specified.
Yeah.
You pick the corner and
Yeah.
And what's that one left?
Yeah, so do me a favor, do just just do those two, leave the other ones alone. Are you gonna do?
Do the bottom.
Yeah, the bottom's fine. So he's gonna put a 10,000 chamfer all the way around, but then on the bottom step that's ½ inch, he left that sharp. So there's the part, that's the part, that's designed exactly how we would do it. Again, there is a print with 3 different prints that take you step by step through the process. There's a video that tells you exactly how to do it, and then to program it. Now, like this one, you got to really pay attention, okay? Like the programming, because programming, not a lot of people really understand it, and you got to catch how easy it is, so that you have the confidence to go in there and do it. Okay, so Billy in the upper left, he's in model. All he's going to do is click that. He's going to drop down to cam. Boom. Okay. Now he can go and program. So what's the first thing we do? The first thing we do is we want to set up our material to show our stock, because the system understands your material, and it will go and get rid of the material. If the material is already gone, it's not going to think that there's anything to go get, right? So the first thing we do is actually we create the stock and establish the X, Y, Z 0. So I'll let Billy go up here. So he clicked, he went up there, it just says setup, right there. You already got it. Then we're in mill. Now model orientation. So we're just going to select Z and X. So what I want to do is I want the back part up there to be on the back of my vise. And then I want my XYZ 0 to be in the upper left with the Y pointed back and the X pointed down this way and the Z is up. So we can see that over here it's kind of messed up, which is not orientated right. So all he has to do is say Z surface, and there's like multiple things he can do. He can click that line, click it, and see now the Z just changed, right? He can just say flip. See it? Now the Z is correct. Go ahead and X out of it, like X out of it. No, not that one. Yeah. Go ahead and go back. Now just that one, just click the top surface of the Z, like just right there, just click it. Boom. And it's already there, right? So you can click the line, you can click the top surface, you can click the construction view, either of the 3. Everybody has different preferences. Okay, so now it's correct. Now we're going to go X, so just click an X line. Boom. X is in the wrong direction, so we flip it. That looks correct, right? Now, stock box point, we want it to be model box point, because we want to know exactly where the model is. So we click that guy, boom, and then we just click the dot up there, and we've established a 0. Now, the part already has material around it, so the see-through part is actually the raw material you're going to cut away, right? So what's the size stock that we have? It's 1x2 standard aluminum, right? And the part is 4 inches. So in the setup sheet, we say 4.1 saw cut, 4.1 plus 30 minus nothing. We understand the size. So Billy goes in here, stock material, and he goes ahead and adds. There's different ways to do it. I like, because we're not going to be even, we will click this guy, put that, and go stock on all sides. And now we know it's 1.9 and 4 inches, so we need 50 thousandths on each of the 4 sides. So he's just going to tab through it. 50, can't see it, but 50, go ahead, tap, 50, and you can literally watch it just change. Now, the Z negative, it knows that it's Z negative, okay? So what we're gonna do is we have to hold on to more stock on the bottom, so we're gonna say 0.230, and you see the stock on the bottom that will get cut off on the second side. So the next one on the top is just 0.02, and then I look at the dimensions, and it shows me my rough stock is 1x2x4.1, which matches perfectly with the setup sheet.
So if you were actually milling this and you had a different stock size, you would put those specifications.
Exactly. Yep. Yeah, whatever you want, really, or you could just adjust some cuts because you know what you know what I mean?
You just measure that with a caliper first before you put those in there?
Yeah, so this is aluminum, so if it's 20,000 off or something, it's not gonna matter. But if a teacher wanted to, add a little extra stock or something, then you can put it in right here. But this basically mirrors exactly. And then from the beginning, you're teaching the student that it needs to be 4.1. So let's make sure that we cut it straight. Check it with a square. Make sure we're good. All right. So go ahead and say okay. Now the Fusion actually knows exactly what, and at any time he can just click it and it'll just show back. So we're gonna face mill it, okay? So one of the cool things is, remember when I talked about brilliant and I mentioned the building blocks? This, I'm just having fun, but all the tools for both of them are in Fusion. So we teach you how to, we give it to you and you just upload it into your own Fusion online. You can basically be at the computer at the school or at home and just open it up and your tools are right there, everything's saved. You don't have to transfer anything. And so Billy is just gonna go off the exact tool list that's in his system, which will be in your system also. And that's these 5 tools that I showed you earlier. First one is a 3-inch face mill. So he's gonna go up to 2D, and he's going to go to face. So then he's gonna go select his tool. He's gonna go over to building blocks. There's the 16 tools that he's just gonna select the 3-inch face mill. He's just gonna say okay. Pull back, show him how the face mill is right there. You can actually move it around. So that's the face mill. That's gonna just cut across the top. So just, we don't have to do speeds and feeds for everything, but on this one, just go ahead and do like 4,000, speed 25, oh you got it, 25, RAM, do 25 and 100, ramp 25, 100. Okay, so there's the speed range. You can put surface foot or chip load or whatever, but that's what they're basically saying, 4,000 RPMs, which is just slow and good for a lot of the educational machines out there, and it's safe as long as your doors are closed. So now he's going to go to the next tab. So it already, see the yellow, how it's outside of it? It already knows where your material's at, okay? So he doesn't have to do anything. Go to the next one. So now he's on retract height. Show him how you can change those. I personally like to know where my top surface, because that's the top of my part. I like to know where it's at. So if I'm 0.4 above, I want it to be 0.4 from the top of the part. So I like to go, personally, I like to go, now he's really showing off like that's how easy it was, but, so show him how you just change that to model top. So model top, so it's 0.3, and you can flip it around, you can see where your zeros are. So on the top height, just go model top right there on your, just do all model tops. That's already there. So at the top, his clearance is at 0.3, his retract height is at 0.2, his feed height is 0.2. That's where it's going to come down before it feeds down into position. And his bottom height, his machining height is at 0 of model top. So that's all he needs. He can look at it, it looks correct. So he's just going to go click the next one. Next one. And on this one, you guys just saw like it started over here and actually machined that way because I have a left-hand stop, and just because the way I put my vices, I like to start on the left-hand side and then move over. That's just me. So you could do where past direction, put 180 there. And then the pass extension, I don't want it, it's going to come off the material and then come into the material, but I want it to actually get off the material, and since it's a 3-inch with a 1.5 being half of the tool, let's just add a 1.6 right there, so it actually leaves a nice finish just trailing right off, and that's it. Go to the next one.
Is that one of those things you can cut corners and save time if you think about?
Yeah, absolutely. Yeah, so like and there's times where I have a whole bunch of parts and then they're all in a row, and then I'll actually get rid of, the second fixture on, and I'll just have this one just go all the way down. You know what I mean? It's your programming mind, like what's the quickest way to do it. So now on this one, he basically doesn't have to do anything. On the 0.3 at the bottom, go ahead and get rid of that because we don't need to leave an arc into it. And then just hit OK. Boom. Do me a favor. Go ahead and right-click face mill and hit simulate. Now watch. He's actually just going to actually run the part like it's in the machine. Okay, now move it around, like move it so I can see the side of it, and then tilt it so I can actually see where it comes off the material and stuff. And I can see the edge, the material, the excess is on. I know it's 50 thousandths, and I know that I went 1.6 off some 100 thousandths. If I wanted to do 1.7, I could, but I can see it. I'm like, oh yeah, it's right there, we're good. And then I actually know that I have a 30 thousandths radius on my thing, so I'm good. So now I have confidence. Remember what I said? You intimately know the toolpath. You intimately know the part. I get it. So one of the great things, one of the most beautiful things on this whole Fusion is adaptive roughing. So the next one we're going to do is tool 2. It's a 3/8 3-flute. So he's going to go to adaptive clearing, 3D, right there. He's going to go to his building blocks. He's going to select his 3/8. Now watch this one. This one is slick. He's going to go to his 3/8. He's going to OK it. Go ahead and, I think we're good with the speeds and feeds. Don't even worry about it. Go to the next one. All right, so it already knows where the stock is at. So, and we're saying rest machining. Rest machining is saying, like, look at the last tool that ran and don't rerun that material. So if he didn't have rest machining, it would go and try to cut the top of the part. But since he has rest machining, it's just going to pick up where we are, and there's no material on top, so it's not going to cut. So go to the next one. All right, so all of this, just go to model top on all. There's a trick here. If you actually are in that pocket and you right click, you can set that as your default. So every time you go to adaptive, it can just come up as model top, or you can keep stock. It's really up to you. I just like to know where my datums are. I like to know where my parts are. So on the bottom height, he actually selected bottom height. So that's not top height, that's the bottom height. And you can see, tilt it up so you can see the Z is already there, right? So what we're gonna do is we're just gonna say negative 10,000 just to get a little bit below it. All right, that looks good. So go ahead and go to the next one. Next one. All right, so now this is like where the important stuff is happening. We have a 3/8 end mill. Okay, so 10% of that would be like 38 thousandths, right? So I'm gonna say, 20%. Let's just go 70 thousandths for a cut. We're gonna go full depth. I'm gonna say 70 thousandths right there, optimal load. Yep, 0.07. Okay, minimum cutting radius when it's coming in so it doesn't like hit square corners. And let's just say 20 thousandths. And this matters because when you come in, if that's too big, when you come into certain corners, you might have left too much material in that corner. You don't want to be like, "Arr!" So 20 thousandths. Machine cavities, we said yes. We're Klein milling. Our roughing step down, just do 1 inch, do something big, because it doesn't matter because it's not going to go below the 760 that we put down. Okay, fine step down 100, that's fine. Stock to leave. This is a roughing pass, so we don't want to finish the outside and everything. We want to come back and kiss it. So this will be a more aggressive pass. So if I was personally doing it, I'd be at like 400 or 500 inches a minute. And I come back and kiss it at maybe 70 inches a minute. But on this one, we're just kind of testing it. So 1 inch, boom, boom. Just do like a 5 thousandths right there for stock to leave. Yeah, 5 thousandths. When he clicks the one, the other one, okay, now go up to the very top, go to the next one. Okay, basically come down until you hit that least right there. Actually, the maximum, stay down up there, put like 5 inches. Yeah, right there. And what that is when you're outside and you're actually making cuts, if you're within 5 inches, it'll stay down and just make those cuts. But if you actually said like 0.250, every time it stops, it would lift up, move over, and come down. So I'm just saying, like, stay down in the pocket, okay? And then stay down distance 5 inches, that's fine. And then go down to least and put 80%. Right above, down, least 80%. No, click on it, yep, 80%.
Is that step over or?
So stay down level, so when it is forced to actually move over and everything, you're basically telling it, try to stay down and only move when you have to. Right? So if I actually was at 20%, it'd want to keep moving out, right? So lead-in transitions, 30 thousandths is fine. No feed engagement. That means when you're cutting, so what we did was we actually are using a peripheral cut. So we're actually going full depth, like we do with titanium. We're taking a smaller radial, but because we're all the way down, we're taking the same surface amount of material, but we're taking it incredibly fast. So it's going to actually machine and actually go back in position. You can actually machine conventional and climb at the same time. it can do that now, but that's not what we're gonna do. But what it does is it machines and it just jams back in position. So you're saying, oh, you can machine at 25 inches a minute, but and don't wrap it, just get back quickly. So let's do 100 inches a minute. No engagement feed right above. Yep. Just do 100. So a little bit faster. So 37 thousandths, that's the lead in and lead out, radius in, that's good. We're doing a helix, so when it drops down and it's not outside the part, which means it's inside, it's actually going to helical down in there, and I'm in agreement with a 2 degree, so we're gonna say that that's okay. And the feed rate, basically, on the first page, we said ramp feed, and I believe it's at 25 or 13, and we're gonna say that that was fine. But it tells you your diameter. One thing that I'm gonna do is, Billy, on this one right here, the entry position, click this guy. And because I'm a student and I wanna see the tool where it comes down and I wanna actually look at it, I don't want it coming to the back of the part, but the back of the vise. So he's gonna click here, so it starts here. And basically just say, okay. You see it loading, and check it out. It roughed the entire part that quick. And we just went through it, but for me, it takes 2 seconds. You just tab like boom, 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 done. And once you just, it's kind of second nature, it's just that quick. So go ahead and simulate this one. Put material on. Okay, go ahead and simulate it. Okay. So and he can actually turn on his, so he has his actually tool path turned off. Go ahead and turn it off just so you can, and then go ahead and make it transparent so you can see the material. Actually, just change the color so it's not green, like material mirror. No, down there. Yeah. Just change, yeah, that's good. All right, so, and then this is gonna adjust the feed rate right here. So like, let's just slow this down a little bit, put it over here. I'm looking at the clock. We're not gonna program all the tools. Maybe we'll do like one more. But I just wanna show you guys. So go ahead and do it. Going a little bit faster. So it started, rotate it. You can rotate it around so we can always see it. Look and show me how much I'm cutting. Like turn it around like so I can see that cut. Yeah, like a little bit more, so you know what I'm saying, right? I want to see the material. I want to be in front of the tool. Yeah. So it took that in one pass because that was 50 thousandths. It was less than 70, which I said. Now it's going to cut this guy. That's 125. That'd be 100.
100 rapid.
25, 100
Yeah.
feed rate. Yeah, rapid. It's a we call it a high feed rate. Yep. And now it's going to go over and it's going to helical right into the. So it's starting at like 100 thousandths, and now it's going into the material. Go ahead and go a little bit faster. So it's going to go down to 495 because I said leave 5 thousandths. And as soon as it hits the bottom, it just starts opening the pocket up. Go ahead and pull back a little bit. So remember, it's feeding at 25 and then it goes back to position at 100. So when I program, so like on a, say a titanium part, I might be at 70 inches a minute right there, and then I'm pulling back at like 200 because I'm dealing with titanium chips and I don't want to like get anything caught and stuff. But if I'm in aluminum, then I'm actually at like 400 inches a minute. I'm pulling back at 800 inches a minute, which is the fastest that we can actually arc machine today. We're getting new machines now, but today 800. Pretty awesome, right? It's just that quick, that easy. And then the tutorial does everything we just did, and all you do is just put the exact same thing in the exact same box. Just copy and just make it happen. Cool. So since it's almost 3 o'clock, do me a favor. Let's just go and just do a drill hole. Actually, let's do a chamfer. So let's do it. Go to 2D chamfer. We're gonna go a little bit faster. So 2D chamfer, it is we're saying it's a 90-degree included angle. So basically, it comes to a point, we're coming off the part, we're dropping down. I like 90 degrees because it's a 45 on one side. So if I'm 50 off, I'm 50 down, I'm edge of tool to edge of material. You guys got me right? And then anything I go beyond that is actually the amount of material. So back in the day, I used to always fake it out, but go ahead and grab the 1/4 inch. Say okay. Don't even worry about speeds and feeds. Just go right there and then select it. So all he's gonna do, he's just gonna select this inside line. Select the inside line because that's the inside of the chamfer, right? He's gonna select that guy. And then he's basically just gonna go to the don't do that one yet. Go to the next one. So you can basically leave everything alone. It says bottom height is 0 because it already knows what it's gonna do. Go to the very next one. So down here where it says cutting chamfer width, I went on the inside line. So I'm already 10 thousandths in. So I'm gonna say 0 because the line established the 10 thousandths. You guys got me? There's 2 lines. I went on the inside, so it already knows how much it went in. And then the chamfer tip would be, say 40 thousandths. Let's just go 60. Go 0 on that. Go 60 on that. And what that is because I'm already 10 thousandths in. That's basically saying take the tip 50 thousandths off and drop it 50 thousandths. Now clearance, put 0. But I'm going to show you how awesome that clearance is. And then basically just hit OK. All right, so there's your tool path. So go ahead and just right click and copy it, duplicate it, right down below, duplicate right there. Okay, and then go in. So right click. He's just going to edit instead of going through the whole thing. Let's just do a similar path. Let's copy, paste, and change a couple things. So get rid of those. Go to the bottom. Now check this out. So my tool is going to hit that side, right? So we're going to come back over here. And now this one doesn't have the 10 thousandths here. So on the first one, I'm going to say 10 thousandths. 10 thousandths. I'll leave that one at, you can put it at 50. And then the next one, put 20. And what that 20 is right there is when the 1/4 inch comes down, it's going to keep it 20 thousandths away from that material. So it doesn't ever hit it. And then go ahead and say okay. And you can see how it started it, and you can see how it kept it off the wall. It actually is going to move in, and it'll get within 20 thousandths of that wall right there. Go ahead and do me go ahead and simulate it. Actually, simulate all of them together. Go ahead and change the color to a different color. Got it. That last one, something happened.
You just use a marking fluid, right?
It's probably something to do with this there. Go back to it. Go to the heights tab. Go to the heights. And then go ahead and select the bottom. Just say selection. Click that guy. Yeah. looks right. Just run it. Run it faster. What's that? Oh, yeah. So we would go back with the contour, we'd kiss it and finish it, but I just jumped forward. Go back in. Go to the last one. Right click, edit. Go to the, go over one. No, over to the right. Over to the right, the fourth one. Click that guy. So 10,000, 20,000, chamfer width. So 10,000 is 50,000. Yeah, that's weird. Maybe it's something we didn't do anything on the back end. Alright, well, I'm not sure right now. You look at my tutorial, and I swear it's correct. Wait, no, I mean, those are 3 lines right there, and one of them, basically, we do this all the time, so one of them is establishing how much over, and the other one is establishing, one is doing the chamfer width, and then the tip, and the clearance. That's only 2,000, what is that? That's a 2, right? 0.2? So weird. Okay. Yeah, I'm not sure. Anyway, it's 3 o'clock, so I'm not gonna spend too much time on it. So, what do you guys think? Like, pretty easy, right? So you guys just watch this up here, but again, you can like literally sit in your room and actually just follow a tutorial. It basically just tells you everything. And then you go from part to part to part and actually machine each part, learn through repetition by actually doing. And it's completely dialed, so.
It's like in the metal shop. Is it in the metal shop or is it around? It's around that complex right next to it.
So weird. So it's 3 o'clock, so it's break time, right? All right, so it is